As the world turns its gaze to the latest Nobel Prize announcements, celebrating achievements across various fields, a subtle debate has emerged around including AI researchers in the physics category. While AI's breakthroughs are undoubtedly transformative, some question whether it belongs within the realm of physics. But as we dive into this debate, it is essential to remember that some of the most profound advancements in technology, particularly those rooted in physics, come from semiconductors. The contributions from this domain have not only reshaped technology but have also been rightly honored with the Nobel Prize in Physics. Let us revisit the pioneers who laid the foundation for the modern digital world. The story begins in 1956, when John Bardeen, William Shockley, and Walter Brattain were awarded the Nobel Prize for inventing the transistor. In the post-war era, their discovery was nothing short of revolutionary. This tiny device replaced vacuum tubes and transformed the landscape of electronics forever. From early computers to smartphones in your pocket today, the transistor is the unsung hero that made it all possible, kickstarting the digital age and laying the foundation for nearly every technological leap. In 1973, Leo Esaki and Ivar Yavor took things further, venturing into the quantum world. Esaki's research into quantum tunneling in semiconductors led to the creation of the Esaki diode, a device capable of operating at incredibly high speeds. Meanwhile, Yavor's work on superconductors and quantum tunneling unlocked new possibilities for understanding and harnessing quantum effects in electronics. Their contributions did not just push the boundaries of semiconductor technology. They brought the strange and powerful world of quantum mechanics into practical applications, giving rise to new forms of high-speed, high-efficiency devices. By 1985, Klaus von Klitzing made his mark on semiconductor physics by discovering the quantum Hall effect. This finding revolutionized how we measure electrical resistance, enabling unprecedented precision in electronics. The quantum Hall effect gave scientists and engineers new tools to understand the physics of semiconductors and continues to play a crucial role in developing advanced materials and technologies. The year 2000 was a landmark for semiconductor pioneers. Jack Kilby, whose invention of the integrated circuit revolutionized the electronics industry, was awarded the Nobel Prize. His work in miniaturizing transistors onto a single chip allowed for the creation of the microprocessors that power every modern computer, phone, and countless other devices. Kilby's integrated circuit became the bedrock of our interconnected world. That same year, Juris Alfarov and Herbert Kromer were recognized for their contributions to semiconductor heterostructures. Their work enabled the creation of faster, more efficient semiconductors, which have powered high-speed electronics, lasers, and optoelectronics. From fiber optic communication to laser technologies, their discoveries propelled our world into a future of faster, more connected devices. In 2014, Isamu Akasaki, Hiroshi Amano, and Shuji Nakamura brought semiconductor breakthroughs back into the spotlight with their invention of blue light-emitting diodes, LEDs, using gallium nitride, GaN, semiconductors. Their work didn't just improve the efficiency of lighting, it fundamentally changed how we illuminate our homes, power our displays, and reduce energy consumption worldwide. Blue LEDs are now ubiquitous in modern life, found in everything from streetlights to smartphone screens. As the world reflects on this year's Nobel season and the ongoing debate about which fields deserve recognition in physics, it is worth remembering the lasting impact of these semiconductor pioneers. Their discoveries have transcended theoretical physics to become the backbone of modern technology, enabling everything from quantum computing to artificial intelligence.